The space industry is at a turning point. NASA's Space Launch System is about to fly. With it, the new Orion spacecraft, a collaboration between NASA and ESA, will target the Moon. A landing is scheduled for 2024. As far as the United States is concerned, low Earth orbit is now the province of corporations, with Boeing and SpaceX competing to break Russia's stranglehold on manned trips to the International Space Station. New technology is cutting costs and increasing launch frequency, with complex satellites being so small they can be deployed in new ways. Several companies are working towards space tourism. Virgin Galactic says its promised trips beyond the atmosphere should start happening soon. Since the retirement of the shuttle in 2011, space science has shifted focus to research carried out on the International Space Station and to robotic missions in deep space. During this period, all manned flights have been to and from the ISS, with the only viable spacecraft being the Russian Soyuz. This has cost both NASA and ESA billions in launch fees. Russia, Europe and Japan, major partners in the ISS, developed their own cargo craft to resupply the space station. But NASA tendered for private companies to take on these responsibilities. Rising star in the launch business, SpaceX, was contracted to develop a cargo craft that would launch on its Falcon 9 rocket.
3, 2, 1, 0. And launch of the SpaceX Falcon 9 rocket as NASA turns to the private sector to resupply the International Space Station.
A second aerospace business, Orbital Sciences Corporation, now Orbital ATK, signed a contract for similar hardware and services. NASA is developing its own launch system and the Orion spacecraft, but it's designed for missions far more ambitious than resupplying the ISS. America's activity in low Earth orbit is being reallocated to the commercial sector, and NASA is helping with technology transfers. Agency administrators want two completely different systems, giving the space agency what they call dissimilar redundancy. When the Space Shuttle twice suffered catastrophic failures, NASA was stuck on the ground for years while exhaustive investigations were made. The redundancy approach will prevent this paralysis. In 2014, NASA signed contracts with Boeing and SpaceX to develop and test human-rated spacecraft to ferry astronauts to and from the International Space Station. It was a continuation of the dissimilar redundancy approach. The space agency has set performance criteria for the new craft and crew training, but is taking a hands-off approach regarding how the companies meet the requirements. Boeing's spacecraft is called the Starliner. It has space for 7 astronauts and will be capable of being used 10 times. NASA requires any human-rated spacecraft to meet higher standards of safety and reliability than a cargo craft, and new capsules must demonstrate, via a series of test flights, that they meet certification.
5, 4.
One crucial part of the new spacecraft is the launch escape system. It's the equivalent of a fighter pilot's ejector seat.
Picture on.
Both Boeing and SpaceX have opted for a new method of capsule-mounted rockets to push the craft clear in an emergency, in contrast to the more traditional escape tower above the agency's new Orion spacecraft. The trial of Boeing's escape system worked well, with the exception that only 2 of the 3 parachutes deployed, but the problem is understood. The Starliner could continue to the next uncrewed launch to orbit. One of the novel features of Boeing's capsule is its ability to return to dry land, like Russia's Soyuz craft. Airbags, stowed behind the heat shield, inflate prior to landing. Without the need to deploy ships for an ocean recovery, there will be considerable savings. Though the capsule can fly on the Delta IV, the Falcon 9, and the yet-to-be-flown Vulcan, initial testing of the spacecraft has been with the Atlas V launcher. The Atlas ground support infrastructure has been modified to accommodate the Starliner with the addition of a crew access arm. The Starliner made its first unmanned test flight in December 2019. Its destination was the ISS. The launch was perfect, and 4.5 minutes after liftoff, the first stage separated. Next, the boost protect covers and the aeroskirt were jettisoned, and the Centaur upper stage burned for a further 7 minutes, following the course parameters perfectly. After separation, the capsule was in a suborbital trajectory, selected because it allowed a safe path back to the ground in case of a malfunction during the boost phase. To achieve the correct orbit, the craft was required to fire its 4 attitude and orbital maneuvering thrusters 31 minutes after liftoff. However, the Starliner's sequence clock was incorrect, and the orbit insertion burn did not happen. Ground control was able to salvage parts of the mission, but the craft was not able to reach the International Space Station. This setback will delay the Starliner's first mission carrying astronauts. SpaceX's Crew Dragon capsule is a refinement of the cargo craft that first flew in 2010. From the beginning, the Dragon capsule has had a heat shield, enabling it to return safely to the ground. No other ISS cargo craft has had this ability. In addition, the Dragon also has a window. This should have been a clue to SpaceX's long-term plans for the craft. In 2014, after the contract for a human-rated craft was signed, SpaceX began work on the Dragon 2. Like its Boeing equivalent, the Dragon 2 sits above a service module that can carry unpressurized cargo and includes a heat exchange unit and a coating of solar cells that does away with the moving parts involved in extendable solar wings. The Dragon 2 can accommodate 7 astronauts, though NASA has said it will generally only send 4 people at a time. Control interface is via a touchscreen. Cape Canaveral's Launch Complex 39A has been equipped with a crew access arm. And in March 2019, in a flight known as Demo 1, the unmanned craft made its first spaceflight. The Dragon carried a dummy astronaut wired with sensors to monitor G-forces and a small delivery of equipment for the ISS. The launch and the phasing maneuvers to align its orbit with the ISS were all correctly executed. The automated docking procedure went smoothly, and the Dragon stayed connected to the space station for 5 days. Decoupling from the ISS went as expected, and observers on the ground were delighted with the capsule's behavior. Throughout the mission, every aspect of the Dragon 2's performance was monitored. The craft's return to Earth was faultless, and the recovered capsule would be reused for the one remaining uncrewed flight test. SpaceX planned to use new capsules for manned flights and then recycle the craft for cargo use. Confident planners at SpaceX and NASA were looking toward the first crewed flight. The final certification test was an in-flight simulation of a booster failure that would monitor the Dragon's launch escape system. But before that, the craft's Super Draco engines, used in mission aborts, needed retesting. This was considered routine and had been carried out many times. A leaked video revealed an explosion that had destroyed the capsule. The problem was not engine failure, but a faulty valve. The flight test of the Dragon 2's escape system eventually happened early in 2020. But just as with the Boeing capsule, which was also well behind schedule, the explosion and the inquiry that followed were another unwelcome delay.
2, 1, 0. Ignition.
Around the point of maximum dynamic pressure, the core stage's engines were cut and the escape system triggered automatically. Shortly after, aerodynamic stresses on the tumbling booster caused it to explode.
Hearing in the room, bright flash there. It looks like that may be Falcon 9 breaking up.
The certification test was a success, and the Dragon 2's next flight will carry astronauts. But there is another spacecraft in development that's worth mentioning. The Sierra Nevada Corporation's Dream Chaser. It's a lifting body craft designed to ride to orbit on an Atlas V, but return to the ground via a commercial landing strip. So far, the Dream Chaser's only flights have been glide tests. As a cargo ship, the Dream Chaser can return a 1,750 kilogram load to the surface. As a crewed vehicle, it is designed to take from 2 to 7 astronauts. The European Space Agency has shown interest in the craft, with the possibility of launching European astronauts atop of French Ariane. The craft will use the bipropellants methane and hydrogen tetroxide for on-orbit maneuvers, doing away with the highly toxic hydrazine. When the space shuttle landed, it had to be at a restricted runway where suited ground staff purged the craft of residual hydrazine. Originally in the running for a NASA contract for ferrying astronauts to the ISS, it missed out because Sierra Nevada could not comply with NASA's 2017 deadline for crewed missions. The favored contractors, Boeing and SpaceX, both failed to meet that same deadline. But the Dream Chaser has a contract for cargo missions to the ISS, and an expendable cargo module known as Shooting Star is being developed. The company still plans a human-rated version of the Dream Chaser, but it's unclear when the craft will fly.
5, 4, 3, 2, 1. Fire in the hole! Fire in the hole!
Cape Canaveral's Launch Complex 17 was the starting point for many historic Delta II missions. Since the demise of the Space Shuttle, NASA infrastructure from the earliest days of spaceflight has been eliminated. Since the heady days of the space race, NASA's budget has been steadily trending downward, and various launch sites have been given over to the private sector. While NASA has been overseeing the commercial craft that will continue to service the research work carried out on the ISS, Its sharpest focus has been on the new Orion spacecraft and the giant space launch system that will boost it to orbit. After its establishment in 1958, the agency's challenge had been to master space technology and then to reach the moon. But since then, the exploration side of NASA's charter has been achieved by robotic missions. Now, a new plan called Artemis will return to the moon. It relies upon the Orion spacecraft and the SLS. The Space Launch System will be the most powerful rocket yet built. And although the design features the latest technologies, most of its components are derived from the Space Shuttle. The Block 1 version, which will send an unmanned Orion spacecraft to orbit the moon, features a central core that owes much to the shuttle's external tank. At the base of the central core are 4 RS-25 engines. The shuttle had 3 of these engines, and NASA still has 16 left over from the shuttle program. Although the engines remain the same, their control systems have been redesigned. Each one has been exhaustively tested, and when the original batch have been utilized, an upgraded version, the RS-25D, will be available. Flanking the central core of the Space Launch System are 2 solid fuel boosters. Again, a refinement of shuttle technology, but with each booster having 5 instead of 4 segments. The new design has been rigorously tested. The boosters will only burn for the first 2 minutes of flight, each consuming 6 tons of propellant every second and providing more than 75% of the rocket's thrust. Unlike the shuttle's boosters, these will not be reusable. The upper stage for the Block 1 configuration of the Space Launch System is called the Interim Cryogenic Propulsion Stage, the ICPS. It's a stopgap modification of the Delta cryogenic second stage used with the Delta 3 and 4 launchers. In 2014, a Delta 4 fitted with this upper stage lifted an Orion spacecraft to its first orbital test. The Orion, with a dummy service module, was boosted to a height approaching 5,800 kilometers, allowing it a high-speed return to Earth similar to a lunar mission. The much larger exploration upper stage was to replace the ICPS for the first crewed mission atop a Block 1B launcher, but design changes have led to delays, and the EUS now won't fly till the 4th Orion mission. The Orion spacecraft itself will comfortably accommodate 4 astronauts for 21 days, with the crew breathing air at atmospheric pressure. The craft is intended for missions beyond Earth orbit. It's designed to integrate with larger modular structures such as habitation modules, specialist landing craft, or the planned lunar gateway. Instrumentation and the control interface are primarily via a touchscreen. The digital control enables weight saving through the absence of wires and switches. The Orion Service Module is the European Space Agency's contribution to the craft. It's derived from the automated transfer vehicle which delivered cargo to the ISS. Oxygen and nitrogen cylinders in the service module supply air. There's a water storage tank, and wastewater is not dumped but recycled. A 4-wing solar array generates 11 kilowatts for battery charging and powering the electrical subsystems. For propulsion and maneuvering, the service module is equipped with a version of the same system used by the Space Shuttle. But like so many aspects of this spacecraft, the system can be easily replaced when alternate models under consideration become available. The third important piece of the Orion craft is the launch abort system, mounted above the capsule. 3 different types of solid fuel rocket are designed to fire at the first hint of a malfunction in the launcher.
1, ignition.
The system was tested in July 2019 above a Minotaur booster, a highly modified peacekeeper missile. Engineers were delighted with its performance. Launch infrastructure is being upgraded for the SLS, and there's increased activity in preparation for the first test of the big new rocket. There were celebrations as the core stage left the Michoud assembly facility. But it hasn't gone to Cape Canaveral, not yet. It was taken by barge to the Stennis test facility in Mississippi, where the stage will be powered up for a series of tests known as the Green Run test campaign. The date, or even the year, for the first launch has been put back a number of times, although it could be as early as 2020. NASA's Exploration Initiative received a jolt in 2019 when US Vice President Pence, the chairman of the National Space Council, called for NASA's Exploration Initiative to be accelerated.
It is the stated policy of this administration and the United States of America to return American astronauts to the moon within the next 5 years. And now's come the time for us to make the next giant leap and return American astronauts to the moon, establish a permanent base there, and develop the technologies to take American astronauts to Mars and beyond.
The existing plan had called for a moon landing no earlier than 2028. The month after the Vice President's speech, NASA announced the Artemis program, Artemis being the sister of Apollo. Late in 2019, companies were called to tender for a lunar lander and for a lunar space station known as the Lunar Gateway. The timeline calls for Artemis 1, an uncrewed Orion craft, to enter a series of looping orbits of the moon in 2020. Astronauts are in training for Artemis 2, due to launch in 2022. The current proposal will see a crew of 4 sent to a retrograde orbit of the moon in a flight that could last as long as 21 days. The powerful exploration upper stage will not be ready for this flight, and its proposed trajectory has been modified to accommodate the limited capacity of the interim cryogenic upper stage. During this time, the Artemis plan calls for commercial launch services to make a series of uncrewed flights to position elements of the Lunar Gateway and Lunar Lander in orbit around the moon. A contract has been signed with Maxar Technologies for a power and propulsion element. Some see this phase of the Artemis program as a weak link, because the US Congress has been reluctant to authorize additional funds. There are no concrete blueprints for a lunar lander yet, and some have suggested that the 2024 deadline is being pushed too enthusiastically. Artemis 3 will see a male and a female astronaut land near the lunar South Pole, where ice exists within permanently shaded craters. Long-term goals for NASA's Space Exploration Initiative include the development of technologies that will enable a landing on the surface of Mars. Finally, a different form of spacecraft will soon be taking passengers. Virgin Galactic will start taking paying customers to space in 2020. Everything about the company's spaceships Enterprise and Unity is reusable, and Virgin is building 2 additional spacecraft. Passengers will experience weightlessness for about 6 minutes. Virgin is also entering the satellite business with a launcher service using a 747 called Cosmic Girl, acting as an air-launched mothership.